Hello and welcome to your Marine Life Lab. Today we're going to be looking at Pacific Northwest marine ecosystems in particular. And in part one, we are going to be creating a couple food webs. So let's look what these actually look like. If we go to the end of the lab, we will see an example of a food web. And this is a food web for a sandy beach environment. And you'll see that there's a handful of organisms, and then there's arrows that kind of indicate who eats who in this particular ecosystem. And so notice that these arrows are going from prey to predator, not the other way around. So our zooplankton is eating our phytoplankton. And hint from the start, zooplankton and phytoplankton show up quite a bit in these food webs. So one thing is missing in this food web that you will have to put on yours, and that is the trophic levels. So underneath the name of your organism also include the trophic level of the organism. Okay, and your food web doesn't have to include illustrations or photos of organisms, but you can if you want. All right, let's go and see what we're actually going to be doing. We just looked at the sandy beach, shallow sea environment. You are going to be looking at the deep ocean pelagic environment, so you'll want to review this term, and rocky beach intertidal zone. You want to review that term too. Each of these two food webs require you to include a couple particular organisms. And these are a great place to get started. A lot of this is going to be figuring out who eats who, and the internet is going to be your friend for this. So you might start with these organisms. Visit Google and figure out what eats a jellyfish. And in turn, figure out what do jellyfish eat. And then what does that organism eat and that organism eat. And go on from there. So you have your two food webs and a couple follow-up questions. Part 2 is also concerned with who eats who. And in this case, we are going to see the effect of increasing or decreasing a population on the other trophic levels. And so this is also going to be figuring out what a razor clam eats, what eats a razor clam, and let's see what happens when that population decreases to almost zero. What happens to the population of predators of razor clams and the population of prey of razor clams. Part 3, we're going to be looking at the difference between bioaccumulation and biomagnification, and then we're going to be doing a little bit of math to figure out how biomagnification works. In this problem, you have a scenario where mercury chloride, which is a toxin, is dumped into an estuary, and it is affecting the organisms in that estuary that consume that mercury chloride. And so you're going to calculate how much of that mercury chloride is accumulating in the organisms of that estuary. So it starts with marsh grass, and we'll do this first one together just to see how it works. So the problem states that this marsh grass is consuming some of the nutrients of the mud and detritus. You should look up what detritus is. That's a fun definition. And that detritus has 20 parts per million of this toxin. All right, so let's start with what we know. We see that the grass is consuming 10 units per day. I'm going to switch to Word so that I can actually type on here. So I'm going to start with what is given in the problem, 10 units per day. And I am going to multiply the units per day by the parts per million in each unit. And that is 20 parts per million per unit. That'll look like this. And then it is just a matter of calculating that through, which you can do on your own. Okay, let's go back to the PDF. One thing I will note is that your answers from Part A and B are going to be used for parts C and D down here. And part D might seem a little daunting at first, but set this up initially as 3 different problems, and then it'll make it a lot easier if you stay organized. Okay, part 4, primary productivity. Here we are going to be looking at graphs in your textbook of the levels of primary productivity at different regions or different latitudes. And then we are going to also look at primary productivity in smaller areas. So here, these are broad regions, different latitudes. And for here, we are looking at more localized areas, like off the coast or near the mouth of a river. And make sure that you are looking at a color version of this lab to answer these. Otherwise, you will not be able to see what these colors mean. Okay, as usual, if you have any questions, feel free to reach out to me and I will do my best to help you out.